Is this on? Oh, okay, good. Thank you. It's always good to be the third person in the session because the other folks do a lot of the introduction for you. We've heard from an NGO which reviewed the history of this technology and a nonprofit that Yuki outlined a lot of the technological challenges that we're facing. Finless Foods is a for-profit, early-stage startup biotechnology food company. We're based here in San Francisco, and we're about 6 months old. And we have specifically targeted fish as our primary focus to implement the cellular agriculture technology that was so nicely described by Yuki in the prior talk. So the reason I got into this was because I was very intrigued by the focus of this particular company in fish. There are other companies that you're probably well aware of that are focusing on terrestrial agriculture products and trying to replace those, namely beef, chicken, pork, turkey, etc. I think one of the things that sets fish apart from those products is that it's really the it's the largest animal food product in the major market that's still hunted and captured rather than raised on farms, and that has certain specific environmental impacts that have to do with the mass fishing industry. Those impacts are distinct from those that we typically think of in terrestrial agriculture. Another interesting thing about fish is that there are numerous and I think incontrovertible studies that indicate that the consumption of fish promotes good health, and that it's a superior foodstuff in terms of longevity, cardiovascular disease, a whole range of age-related diseases, as opposed to eating something like beef. And I think that the primary reason that those health benefits accrue is due to the specific lipids that are present in fish, both the absence of deleterious lipids as well as the presence of beneficial lipids such as omega-3s, which are extremely rich in certain fish species. So that's sort of a pitch for fish in general. The problem, however, is that captured fish as well as fish raised in farms are increasingly drifting away from those health benefits that we tend to think of associated with fish consumption. In particular, on the upper left, you can, it points to the fact that accumulation of mercury in captured fish is a big health problem. The farther up you go up the food chain, the more you bioaccumulate mercury, and I believe that the sort of medical establishment currently advises pregnant women to avoid tuna completely, and children to limit their intake of tuna to once a week. And I think that really underscores the serious medical risks associated with eating a primary predator fish like tuna, which people enjoy. So we want to, kind of make tuna that allows us to avoid those risks. Okay, so from an environmental point of view, this graph shows the actual and projected capture and aquaculture data for fish, and you can see that the total fish consumption is projected to be in excess of 180 million tons per annum by 2029, which is putting extraordinary pressure on the sea environment. The lower two lines, the yellow and the magenta, show that there's a convergence, if you will, of the relative contribution of captured fish in the yellow to aquaculture in the magenta. And it's projected by this source that in 2029, that the amount of aquaculture will essentially be the same as the amount of captured fish. And I think that that has a lot to do with the fact that captured fish are endangered and aquaculture is kind of taking up the slack. There are very specific environmental and health risks associated with aquaculture, not the least of which is that even the most fastidious aquaculture farms rely heavily on antibiotics in order to maintain their stocks in a disease-free environment. And those antibiotics find their way both into the environment and into the consumers. So I guess my point here is that aquaculture is different in the environmental and health risks that it presents as far as captured fish, but it presents its own set of risks. So the solution to getting away from both aquaculture and captured fish is to produce healthy fish in vitro, much along the lines that, and the technologies that were outlined in the prior two talks. And so the ultimate goal is for us to be able to construct things that look like this without actually having animals in the supply chain. And that's going to require a lot of technological know-how, but I feel like we have a handle on the problem. So this is our basic workflow, which I think was kind of outlined in the prior talk, but I'll put my own spin on it. We identify high-value fish, isolate primary cells from those fish, and coax them into being amenable to large-scale production. And we scale that up into bioreactor-level growth at in excess of 1,000-liter scale. And also, it requires that we be able to differentiate these primary and stem cells into terminal fates that are appropriate for consumption. And those terminal fates would, not surprisingly, be muscle and fat, which are the two primary sort of material and flavor ingredients that we enjoy in fish. Drain and strain, which means we basically remove those from the culture media. And then structure and package. This rather simplistic statement number 5 is actually very complicated. This concept structure requires very sophisticated tissue engineering technology that we're adapting from the medical world, sort of thinking about how people print artificial organs, and we're basically wanting to print sushi and fillets, and then, of course, distribution. So I think from a commercial point of view, one of the reasons that Finless Foods is very competitive in this for-profit market is the fact that in relation to terrestrial livestock like chicken and pork, the prices that are commanded by something, say, like bluefin tuna are quite a bit greater, depending on how it's sort of packaged and distributed. Bluefin tuna can sell for up to $1,200 a pound, which is significantly higher than that of, say, chicken or pork. So we feel like, as an enabling technology, we're a step ahead in terms of being able to go to market quickly because of our ability to be cost competitive vis-a-vis terrestrial livestock. So our go-to-market strategy is segmented into two goals. The first product is surimi, and I feel as though in this audience I don't need to necessarily explain what that is, but it is a fish cake, which is typically around 20% fish, usually a low-value fish like pollock, that is compounded with plant-derived material and turned into a cake-like product that's steamed and comes in many forms. And the reason that we want to focus on this as a first product is because it allows us to, at least initially, not have to solve all those tissue engineering problems and get to market while we solve the tissue engineering problem. But eventually, we want to produce versions of this which will be a much higher value product, but from a technological point of view, presents greater challenges that we're working on in terms of fabricating something like this and printing a material that has this structure of layered different cell types. Okay, so cost. Cost is a big problem, and we are currently in the sort of 1,000 to 10,000 order of magnitude range per pound in the lab, and we project that by 2021 we'll be in the $10 range, and that will largely be due to our perfection of controlling costs through media, as Yuki referred to, and getting this very expensive commercial products like fetal bovine serum out of the production chain. So I more or less referred to this, but this is our distribution model, which is to initially go to restaurants, and as we build consumer acceptance and knowledge through restaurant distributions, then the second segment of that is to go to retail, i.e. selling the stuff in grocery stores. Very quickly, you can see that in vitro fish production from a distribution network point of view frees us from having to source things from coastal regions and move them inland. Fish could be produced anywhere in the United States and distributed locally. This is also another distinction, I think, from terrestrial livestock. End user interest. We've had extraordinary interest from media, and people seem very thrilled about this idea of making fish in vitro. And if you Google us, you can find any number of articles and videos that talk about our work. These are our founders, Brian and Mike, that went to college together many years ago. Well, actually not that many, but they were the people who conceptualized this and really made it happen here at IndieBio here in San Francisco. The rest of our team as of today is me, Ji-Hyun Kim, who is a stem cell and cell biology expert, and she's running that part of the business, and Torin Yeager, who is a tissue engineer who's really focused on the scaffolding problems and solving those. They're both in the audience. We have a number of advisors, including a bioprocess engineer and a surimi expert. I'm almost out of time here. This is kind of our timeline for what we're hoping to achieve, which is these things in green we've already done. We've unveiled our first prototype as early as September 18th, and we plan to have sashimi in restaurants by 2022. This is a picture from our first public unveiling of a fish burger, and this is what the starting material looked like under a microscope that led to the formulation of the world's first cellular fish burger. So with that, thank you for your attention. Thanks.